Hi guys, in this video we're gonna go through some trigonometric limits, starting with simple ones like these. You can pause the video to try them out. To evaluate these limits, we need to know by heart some basic limits like this. The limit when x approaching 0 of sine x over x is 1. The limit when x approaches 0 of tan x over x is 1. Limit 1 minus cosine x over x is 0, and the limit of 1 minus cosine x over x squared is 1/2. We can deduce from this one that the limit of sine f of x over f of x is also 1 if f of x is approaching 0. So to start with this one, if we had sine 5x over 5x, it's 1. Because when x approaches 0, 5x also approaches 0. But here we have 4x. So we need simply to multiply here by 5 to get 5x, and then multiply here by 5. So it's the limit x approaches 0 of sine 5x over 4x. I multiply by 5 here and 5 here. So we can switch the places of the 4 and the 5 to get sine 5x over 5x. It's the limit x approaches 0 of sine 5x over 5x times 5 over 4. We can take this out, so the limit, we have this rule, and this one is equal to 1. So it's 5 over 4 times the limit of sine 5x over 5x, x approaching 0. So it's simply 5 over 4 times 1. This equals to 1. And we have 5 over 4. The second one, we have the limit of 2x over tan 7x. If we had here 7x, it would have been easier, but we can multiply by 7 and divide by 7. The same thing as before, it's limit x approaching 0 of 2x over tan 7x. I multiply by 7 on the top and 7 on the bottom, and then switch the 2 and the 7. So it's the limit x approaches 0 of 7x over 10x times, don't forget that I switched to places, 2 over 7. this limit is 1. I take this 2 over 7 out, so it's simply 2 by 7 times 1, which is 2 by 7. The third limit is the limit when x approaches 0 plus. It's a handwrite limit because we've got here the square root of x. X cannot be negative here. So 1 minus cosine square root of x over x. So this reminds us of this one. If you look deeply here, you can see that if we put y equals to the square root of x, then x would be y squared and the square root of x would be y. So putting y is the square root of x, you get y squared equals x. So by substituting here, you get the limit of y approaching 0 plus. Because if x approaches 0, y would also approach 0. So it's the limit of 1 minus cosine y over y squared. And this is clearly this usual limit here, which is 1/2. The last one, here we've got the limit x approaches 0 of 1 minus the square root of cosine x over x squared. We do not have this one here, so we gotta get rid of the square root here. So you might think that multiplying by the conjugate would be a good idea, because if I multiply this by its conjugate, it's gonna be 1 squared minus this squared, and this would rid us of the square roots. So it's the limit x approaching 0, and I multiply by the conjugates. It's 1 minus cos x. The conjugate is 1 plus square root of cosine x. And I need to multiply by this at the bottom. X squared 1 plus square root of cosine x. So it's the limit x approaches 0. This is, we saw this in a previous video. It's 1 squared minus this squared, which gives us cosine x over x squared times this. I'm gonna put this at the side because I know this limit. So it's times 1 over 1 plus square root of cosine x. This is usual and it's 1/2, and if I put in here 0, so cosine 0 is 1, square root of 1 is 1, 1 plus 1 is 2, so this is 1 over 2, and this is 1 over 2. So it's the limit of 1 minus cosine x of x over x squared times the limit of this x approaching 0. This is 1/2, we know it. This is 1/2, and this, by plugging in 0, we get 1/2. So it's 1/4. Thank you guys, and see you in the next video.